In this problem, we're told how much taller does the Eiffel Tower become at the end of the day when the temperature has increased 15 degrees Celsius. Its original height is 321 meters, and you can assume it is made out of steel. So when you do these problems, you want to imagine it's just one long beam. And so we're also told the initial height, which is 321 meters. And what we're trying to find is how much taller something gets. So we're basically going to be just solving for the change in length. So how much longer this rod gets, or this beam. So we're trying to find delta L. So I'm just going to say delta L equals question mark. And so what other information we're given? We're given the initial length, or the height. They tell us it's 321 meters. So we know the initial length is 321 meters. They also tell us we're trying to find the change in length, right, when it's increased 15 degrees Celsius. So they're basically telling us delta T, or the change in temperature, which is 15 degrees Celsius. And so the final thing they tell us, not directly, but they tell us it's made out of steel. And so when we solve this problem, we're going to be using a formula which basically has a value alpha. And basically alpha is the coefficient of linear expansion, which is different for every material. And in this case, they tell us it's steel. And so if you look in your textbook, in the tables, it'll say the value. And in this case, it's 12 times 10 to the minus 6. So just keep that in mind. And so what we're trying to find is delta L. And so luckily, there's a formula that just relates all these values. And so the change in length is equal to the coefficient of linear expansion, right? So alpha multiplied by the initial length times the change in temperature. So if we know these three values, we can find the change in length, which is exactly what we want. We're trying to find how much taller it gets. And so all we have to do is just plug in the values. So we know alpha is 12 times 10 to the minus 6. They tell us the initial length is 321 meters. And then they tell us we're going to be increasing by 15 degrees Celsius. So the change is 15. And so you can see right here, since this is in degrees Celsius, this is inverse degrees Celsius, these will cancel. And then this was in meters. So the change in L is meters, which is exactly what we want. So yeah, so delta L. And then you just gonna want to plug in these values in your calculator. So just do 12 times 10 to the minus 6. Multiply that by 321. And then multiply that by 15. So you're going to get a pretty small number, which makes sense because it's only changing by a little bit, or the temperature is only changing a little, and so it's not really going to expand that much. But you're going to get 0.05778. So 0.05778. You can round if you want. I'm just going to leave it like this. And so keep in mind, this is going to be in meters. So how much taller it's going to get? Well, we know its length is going to change by this much. So this is how much taller it's going to get. So 0.05 meters essentially. But yeah, so this right here is going to be your answer, and hopefully you found this useful.